How do you solve exponential and logarithmic equations? The secret here is this, students. If they have the same base, you can cancel them out. They're inverse operations of each other. If one's a log, one's a base of an exponent, you can cancel them out. What am I talking about? Let me show you a couple of examples to show you. Now down here I have the properties. These ones are in log form. This is a natural log form. They're the same exact properties, but one's written with the ln, one's written with the log. So let's see how this works out. It starts off a little clear, and then it gets a little more cloudy as we go. Here we go. For this first one, now I'm trying to solve for this x right here. How do I get it out of the exponents? Well, I'll have to get rid of this base e. What is the inverse of base e? ln, which is natural log. So natural log of base e to the x equals natural log of 4. You see, if you do it to one side, you must do it to the other side. And check it out. Natural log is log base e, right? I'm just writing this for visual purposes. Log base e of e to the x. So see, look, they have the same bases. Same bases. That means you could cancel them out. So natural log cancels out with the base e, and you're left with x on the left side, and on the right side you have natural log of 4. That's your answer. We're following the basic equation principles. Like if we had, we'll say we have 5x minus 4 equals 11. If you add 4 to this side, you must add 4 to that side. You see, if I did a log to one side, I must do a log to the other side. If you do an operation on one side, you must do the operation to the other side. And so now I have 5x equals 15. What's the next inverse operation I would want to do to get this x alone? I would divide by 5, so I divide by 5, and I get x equals 3. Oh yeah, I got a pretty answer for this one. Okay, let's look at this one right here. Now we're just trying to solve for x. This is only a one-stepper right here. So what I need to do is I need to get x alone, and right now x is inside this logarithm, this natural log. How do I get rid of this natural log? Raise it to the what? Base e. And so since natural log has a base e, and this is a base e, then they cancel out. If they have the same bases, they cancel out. I'm left with x equals e to the 4th. And that's your answer. Now treat e like it's pi. Okay, e is just like a pi, where you don't have to simplify it all the way. It's an irrational number with a decimal that goes on forever and ever and ever. Yeah, it's a 4. Now here I chose base e, but let's say if we had, what if we had this? What if we had log base 5 of x equals 4? Well, how would I get rid of this log base 5? I'll raise it to the base 5. Now, you want them to have the same bases. Now here you don't see the base because we have a special way to write log base e. That's natural log. And so we know it has a base e, but if it's something like this, you raise it to the base 5, then they'll cancel out. And then you're left with x equals 5 raised to the 4th power. And you could simplify that. That's fine, but that's your answer. That's how you get the x out of the logarithm. All right, so here we go. Here's our next one. What you want to do first is you first want to get the exponential part alone. You can't raise this, or I'm sorry, take the natural log of this. That will not cancel out the e because there's a plus 3 right there. So what you have to do is you have to get rid of the plus 3 first. So we're going to subtract 3 from both sides, and now we have e to the x equals 1. Now as you guys get more and more used to seeing this, you should know the answer right away. What is e to the x? What is x if it equals 1? If you're not sure, don't worry. I just want to practice using inverse operations. What's the inverse of having a base e? Natural log. That's right, because natural log is log base e. We want them to have the same bases. Whatever you do to one side, you must do the other, so I have to go natural log of 1. So I have natural log of 1, and then just an x, because these two have the same bases, they get canceled out. Now I have a logarithm with a 1 in it. Look at it. Look at this. If you have a log with a 1 in it, what does it equal? 0. You have a natural log with a 1 in it, what does it equal? 0. Whenever you have, if you're taking a natural log or log of 1, it always equals 0. Why? Well, let me show you. Let's take my log base 5, for example. If we were doing log base 5 of 1, you're saying, okay, what does this equal? Well, what this really means is 5 raised to what power equals 1? Because the inside of the logarithm is always what it equals. And so the exponent would be 0, which is why x equals 0 right here. Next one is a logarithm, a log equation. To solve this, kind of like this one right here, you had to get rid of the 3 first, so you can do like an inverse of that base e. You're going to do the same thing here. Let's get rid of the 3 first, so we can do an inverse of the natural log. So we're going to subtract 3. That's going to be natural log of x equals 1. Now, how do I get rid of this natural log here? I want to get this x out of it.
Base e.
Base e, because it has a base e. Natural log has a base e. So I raise both sides to the base of e. Then I have, cross those guys out. I have x equals e to the 1, and you don't need to write the 1. It's just x equals 1. Whoops. Or I'm sorry, x equals e. Okay, next. Only have one more slide after this one. Okay, so now again we're going to get rid of this 3 right here. Now we have e to the 3x minus 3 equals 1. Okay, a little bit more work to do here because there's more going on inside of our exponent. How do we get rid of the base e? Natural log, because natural log has a base e. I'm going to write it differently this time just for practice. Log base e. I want these to have the same base so that I could cancel them out. On the other side, I'm going to have log base e of 1. Now you should never write log base e. You should write natural log. This is just for practicing purposes. Do you guys know what this is whenever you have a 1 inside of a logarithm? Yeah, you do. What is it? Come on. Yeah, 0. So you have 3x minus 3 equals 0. You add 3 to both sides. You get 3x equals 3, and then x equals 1. Check out this next dude. Similar operations again. Subtracting 3. We have equals 1. We have a natural log of 3x minus 3. Some of you guys are like, okay, I get it. Let's stop writing stuff. If you get it, stop writing stuff. Okay? I'm just, want to make sure I'm thorough so you guys can see everything. Okay? This is a new way of solving equations. It's a new inverse operation. I want you guys to be used to it so you can rock the house with it. How do I get rid of a natural log? Yeah, raise it to the base of e because that's the base. What if it was log base 2 of 3x minus 3? What would you raise it to the base of? Yeah, let's say this is 1. You would raise this to base 2 so that you can cancel them out, but then you have to raise the other side to base 2. And this would equal 3x minus 3 equals 2. Because 2 raised to the 1 power is, I'll just go 2 raised to the 1 power. Okay, that's kind of on the side right there. Actually, you're going to be in my way, so I'm going to move you. Okay, and then, oh yeah, these guys cancel out. I'm left with 3x minus 3 equals e, because e to the 1 is e. And I add 3 to both sides, so I have e plus 3, 3x right here. And then how do I get my x alone now? What do I do? Yeah, divide by 3. So I have x equals e plus 3 divided by 3. And I like that answer. That answer is good. Or you can divide each of these by 3, and you can write it this way. E divided by 3 plus 1. So I would take both these answers, but you guys should know how to go back and forth between the two. Alright, now let's do the last slide. Boom. Okay, still have the same properties. See, same properties down here. We're using the same properties, and why does this look different now? Oh, we're not using the e anymore. Oh, look, we're not using the e anymore. We don't have a natural log. We have a base 9. Okay, so let's get crazy. The first one, I'll use my blue marker here. We're going to subtract 3, so now it equals 1. I've got to get the base alone before I can do a log to it. Now, how am I going to get rid of that base 9? Log base 9. Notice, though, I am picking pretty numbers. You see how it equals 1? I know it's going to end up pretty. So log base 9 to both sides. So now I have, those cancel out. 3x minus 3 equals, I'm going to write this one out first, log base 9 of 1. What is log base 9 of 1? 0. Because there's a 1 inside the log. Whenever there's a 1 inside the log, see right here? It equals 0. Now why? Well, translate this to an exponential form, and you'll understand why that whenever there's a 1 inside of a log, it equals 0. Okay, so I add 3 to both sides, I get 3x equals 3, x equals 1. That's my answer for the first one. Now we'll go to the green. We subtract 3 from both sides, it equals 1. We have log base 9 of 3x. I love that I'm looking up and I'm seeing everybody, or not everybody, but a lot of people stop writing because you're like, I got this. That's good. Alright, so how do I get this 3x minus 3 out of the log? Raise it to base 9. So these cancel out right here, and I'm left with 3x minus 3 equals, what's 9 to the 1 power? 9. I add 3 to both sides, so I get 12 equals 3x. X equals? 4. Boom.
So now you're not going to model.
And that's it.